one more thing regarding one proportion. Whenever we can do confidence intervals, we can also do hypothesis testing. This one is a recap. We've seen this several times. What do we do when we do hypothesis testing? We need the hypothesis, we calculate, we look at the data, we find the p-value, or we base the conclusion on a critical value, either or. That's what we do. Same thing we've done a number of times. Here is how the hypothesis could be stated in this case. And now there is a room for confusion here, because usually we use the letter P for all sorts of probabilities for the obvious reason. P, probability, right? So P is used for many probabilities. It's also used for the probability in our binomial theory, right? It's used for the underlying proportion of left-handedness because it goes with the binomial when you check one person at a time, are you left-handed or not. So this underlying proportion, population proportion of left-handedness becomes the P of individual binomials when you start sampling. So that is the parameter of interest that we could express our hypothesis in terms of. But at the same time, we also talk about p-values to express the p-value probability in relation to the hypothesis test. That's also a p, but it's a different p, right? It's just to make you remember that p is a generic name for all sorts of probabilities. Sometimes probabilities play the role as the mu, right? We don't have a mu here, or actually there is a mu, because the mean in a binomial with n equal 1, that's p, right? So the p here is actually a kind of a mu, but we call it p because we usually do that in a proportion setting. Here we go. How do we make that test? Well, there are several ways. Here's one. Again, if the sample sizes are large enough, now defined by the hypothesized p, they should be large enough. We make the comparison between the observed number of successes, or whatever we count, and, can you see that, the expected number of counts. And then I use the binomial standard deviation in the denominator, right? So it's actually the usual mean by hypothesized mean divided by the standard error of the mean. It's the same hypothesis test structure as we've seen a number of times in the course. And then we use a standard normal probability to make conclusions. Conclusions in the same way that we've done many times in our course now. Let's exemplify. Before we exemplify, I'm going to exemplify and then I'm going to show you the two slides just to make it clear. I'm going to make some maybe funny hypothesis, maybe I never read a single thing in my life, and I had the idea, hey, probably we have two hands. It's a 50-50 thing whether we become left-handed or right-handed, right? There are only two we can choose that God can choose among. He probably throws the dice for this thing about the hands. It's just a minor thing in the big perspective. Hey, who cares? So it's a 50-50 thing. That could be a basic hypothesis, right? So I could hypothesize the 50-50 thing, and I could have the alternative that it's not 50-50, right? How should I test that hypothesis? I do it like the formula just showed you, by using the observed number of people that was left-handed in my sample, that was 10, comparing with the expected number that should be there if it should match the hypothesis, that would be 50, right? There should be 50 if the hypothesis should be exactly true. And then I compare by the binomial standard deviation using the 0.5, the P0 here. And I get an observed test statistic. I call it set because I want to use, as I said, the standard normal distribution of -8 in this case. Then I show you the two previous slides where that these are the general slides that goes with this hypothesis test, that it could have been a one-sided hypothesis test. In other contexts, maybe. We've seen that before. Sometimes it's one-sided, sometimes it's not. We're in the two-sided case, so if we're in the two-sided case, we find the set ups. One way of putting it into the positive side, we take this probability and I multiply it by 2 to get both tails. This is one way to express it. I could also have taken minus and then taken 2 of those tails. Now I do it this way, right? Or it could be one-sided. Or this is the p-value approach to find the p-value. Or we could, in the two-sided alternative, find the standard normal critical value. What is the standard normal critical values with alpha equal 5%? Two-sided critical values when alpha equals 5%. What is the value that the statistic should be beyond to be expressing a significant effect or a significant rejection of the null hypothesis? What's the number? Please, in the back row. 2, correct. 1.96. The p-value first. What is the probability that a standard normal goes beyond 8? That is pretty small, right? I think hopefully you would have known that. Standard normal is sort of having its life on +/-3, and then beyond +/-3, basically nothing is going on. +/-2 includes 95%, +/-3 includes 99-point-something%, +/-8, whew, that's a large number, and going beyond 8 is almost as small as the computer is able to find for us. So we have strong evidence against the 50-50 hypothesis, of course, right? Or, to repeat the critical value thing, I see that my observed setups was way beyond the acceptance region in the middle. So I reject, of course, right? That's the critical value way of saying it. So that was actually the first 4 things. So I will now let you spend the last 4 minutes on this one, and 1 more minute to have a chat with you about what the results are. It's probably more readable if you open it in your own device. Or I could enhance a little bit. So we made a poll. There are some candidates. 30% said they voted for candidate A, say. So 300 out of 1,000. I'm asking you, what is the sampling error of this proportion? And I'm telling you, I may just have put in more than one. Maybe, maybe not. Correct answer. There is more, at least one, I assure you. I'm not tricking you. At least one of them are correct, and there could be more. You may discuss with your friends. Actually, I think I will make the break and then have a look at the results when we start immediately after the break. So you may finish your answers during the break if you like, or you may just break. It's a free country. We'll start again 15 minutes from now.